Today we're going to look at section 5.4a. We're starting to focus on dividing polynomials, and we have two different techniques. Today our technique is going to be long division. This is a technique that will work for any polynomial division. So first, before we start with the polynomials, let's just look at what happens with regular numbers. If we have 514 and we're dividing by 11, that means we have 11 out front, and we're looking for how many times it goes into 514. So we start with the 5. Does 11 go into 5? No, it's not big enough. So then we move over. Does 11 go into 51? Yes, it would go in 4 times, and 4 times 11 is 44. We then subtract, so 51 minus 44 would be 7, and we bring down the 4. And then we just keep repeating the process. Does 11 go into 74? Yes, it would go in 6 times. 6 times 11 would be 66. We subtract, and we have 8. Does 11 go into 8? No, it's too small, so that is our remainder. So we would put our answer down as 46 and 8/11. 8 is being divided by 11. It's just not big enough for it to be a whole number. So how we apply that to polynomials. Our first example, we have 4x squared plus 23x minus 16, and we are dividing by x plus 5. So our x plus 5 goes out front. And for polynomial long division, you are going to focus on first term in each piece to figure out what we put on the top. Okay, so we take 4x squared, we divide it by an x, and we have 4x left. That is what goes up on top. Okay? Then we actually take that 4x and multiply it to this whole thing. So we are going to take, let me erase that here. We are going to take 4x times x plus 5, and that's what's going to go underneath. So 4x times x would be 4x squared, and 4x times 5 would be 20x. And our next step with any kind of long division is to subtract. But here's where you have to be careful, because you are subtracting this whole binomial. Okay? So we now have 4x squared. We're subtracting 4x squared. That will drop out. If it doesn't, you've done something wrong. That first column should always drop out when we subtract. Then we have 23x, and we're subtracting 20x, so we would have 3x left over. And we then bring down our negative 16, and we repeat the process. So we focus on the first term, our 3x, and we're going to take 3x and divide it by that first term in our divisor, the x. That gives us a 3. That goes on top. It's a positive 3. And then we multiply to all of this. So 3 times the x plus 5, and that's what goes underneath. So we get 3x plus 15, and we have to subtract all of that. So again, that first column should disappear. 3x minus 3x would be 0. We have negative 16 minus 15. That puts us at negative 31, and that is our remainder. There's no more x's to try to divide out. So our answer would be 4x plus 3, the stuff we had on top, plus we have this remainder of negative 31. It's being divided by an x plus 5. All right, let's try another one. This one says x cubed plus 7x squared plus 14x plus 3, and we are dividing by x plus 2. So our x plus 2 goes in front. We have an x cubed. We have a positive 7x squared, a positive 14x, and a positive 3. All right. How many times does x go into x cubed? Again, remember we are focusing on the first term only. So x cubed divided by an x would give us x squared. That's what we're going to put up on top. as part of our quotient, our answer. Then we take x squared, that top piece, times this whole thing. So x squared times x plus 2, and that's what goes underneath. X squared times x would give us an x cubed, and x squared times the 2 would give us 2x squared. And remember, we are then subtracting. Our first column drops out, x cubed minus x cubed. Then our second column, we have 7x squared. We're subtracting 2x squared, which leaves us 5x squared. And we bring down our next term. And then we repeat that same process. Our first term, 5x squared, divided by the first term in our divisor, the x. We end up with 5x. That's going to go on top, a positive 5x. And then 5x times the whole divisor, x plus 2. That's what goes on the bottom. So we get 5x squared plus 10x. And we subtract. Our x squareds drop out. Our x's, we have 14. We're subtracting 10, which means we have 4 of them. And we bring down our 3. And that's the last one to bring down, so this will be our last round. We take 4x divided by our first term x, and we get a 4. So a positive 4 is going to go up on top. We take 4 times x plus 2, which gets us 4x plus 8. And we then subtract. So our 4x minus 4x is 0. We have 3 minus 8 gets us negative 5. That will be our remainder. So my answer will be written as x squared, all of this, x squared plus 5x plus 4, plus this remainder, and what it's being divided by is x plus 2. All right. Our next one. We are dividing by an x minus 3. We have 2x cubed minus 2x squared minus 5x plus 7. Okay, so once again, first term, 2x cubed divided by our x. We end up with 2x squared, and that goes up on top. And then remember, our top number gets multiplied to this whole thing. So we have 2x squared being multiplied to x minus 3. We end up with 2x cubed minus 6x squared, and we are subtracting those. So our cubes are gone. Be careful here, we have a negative 2x squared and we're subtracting a negative 6x squared. That means we're really adding 6x squared, so we should end up with 4x squared. That subtraction process is where most mistakes happen, so be very careful there. Bring down our next term, negative 5x, and repeat our process. So we're going to take 4x squared, we're dividing it by an x, which leaves us 4x. That's going to go on top. We're going to multiply that 4x times our whole divisor, and we get 4x squared minus 12x. And then we subtract that whole thing. So 4x squared minus 4x squared, those are gone. We have a negative 5x. We're subtracting a negative, so we're really adding 12x. We end up with 7x. And we're going to bring down our last term and repeat our process. So first term divided by first term. Our 7 goes on top. We multiply 7 times x minus 3, and we end up with 7x minus 21. And then we subtract. Again, our x's are gone. 7 minus a negative 21 is really 7 plus 21, or 28. So, final answer, 2x squared plus 4x plus 7 plus an extra 28 that's being divided by an x minus 3. So that's our little fraction remainder. All right. Notice that on the last two questions here, we are not dividing by just an x plus or minus a number. We now have a 2x plus 1 as our divisor. We're dividing it into 6x squared plus 7x plus 2. The process is the same. First term divided by first term. So we have 6x squared, we're dividing out a 2x. That leaves me a 3x left. That goes up on top, and we take 3x times our whole divisor, 2x plus 1. 3x times 2x would be 6x squared. 3x times 1 is 3x, and we subtract. So our x squared column drops out. We have 7x, we're subtracting 3, so we end up with 4x, and we bring down our positive 2. Repeating that process, 4x divided by 2x leaves us leaves us just a 2. That goes up on top, a positive 2, and then we multiply to all of that. So we end up with 4x plus 2. And when we subtract all of it, everything drops out. 4x minus 4x is 0, 2 minus 2 is 0. That means we have no remainder. And that's going to be really important as we continue on in this half of our chapter. We are looking for things that have no remainder, because that means it's a factor of it. So my answer to 6x squared plus 7x plus 2 being divided by 2x plus 1, my answer is just 3x plus 2. There's no remainder piece. One thing to remember about that also means that if we multiplied this and this, we should get back to our original polynomial. Okay, so it means that 2x plus 1 times 3x plus 2 should give us 6x squared plus 7x plus 2. Okay, so if there's no remainder, it means it went in evenly. It is a factor of that expression. Our last example is slightly different. Our statement here says if any term of a polynomial is not expressed, make sure to represent it with a 0 in the long division process. It's kind of like saying if I was dividing 7,052 by 21, I have to have that 0 there. It's holding that place value. I can't just put 752 because now I have 752 instead of 7,052. So it is important that any terms that are missing, we just put a 0 in their place. So our divisor, 2x minus 5. We are dividing it into 2x cubed minus 9x squared. And now notice there's no x's, so I'm just going to put plus 0x plus the 15. Okay, I need to hold that space. Otherwise, my columns aren't going to line up correctly. All right, going through our process again. Well, first term, 2x cubed is being divided by a 2x. That leaves me just an x squared. Then I take x squared times 2x minus 5 to figure out what I write on the bottom. So I have 2x cubed minus 5x squared. We're subtracting, so our cubes drop out. We have a negative 9, and we're subtracting a negative 5. So we're adding 5 to negative 9. We have negative 4x squared. Then we're going to bring down our 0x to hold that spot. We're going to repeat our process. So negative 4x squared, first term, divided by first term. We end up with negative 2x. That goes up on top. And then we're going to multiply that negative 2x times our whole divisor. So we have negative 4x squared. And we have a positive 10x. And then we subtract all of that. So again, our first column is going to drop out. We have 0 minus 10 puts us at negative 10 for our x's, and then we're going to bring down our 15. One last time, we're going to take our first term, negative 10x, we're going to divide by 2x, leaves us a negative 5. We put that on top, and then we multiply negative 5 times 2x minus 5. We get negative 10x plus 25, and then we subtract. Our x's drop out. We have 15 minus 25, so we're at negative 10 for our remainder. So my answer to this is going to be x squared minus 2x minus 5 plus my remainder is negative 10, and we were dividing by 2x minus 5. All right, so for today you are going to just work on this long division process. Tomorrow we're going to look at a shortcut that can sometimes be used called synthetic division.